Coral reefs are the rainforests of the ocean, home to 25% of the world's fish species and a basis for 10% of the world's protein diet from fish. The coral reefs themselves cover over 600,000 square kilometres of the Earth's surface. Coral reefs act as natural coastal defences for 109 countries around the world, acting as natural offshore wave defence and protecting coastlines from erosion and flooding. The coral reefs themselves bring in $375 billion a year in annual revenue for worldwide tourism, fisheries, the aquarium trade and pharmaceuticals. They also act as nurseries for juvenile fish to shelter and grow up, which support the major fisheries around the world. Indirectly, the corals could be used for novel pharmaceuticals. They balance larger ecosystems, fix CO2 and are feeding grounds for major predators as well as sediment retention. But 33% of reef building corals are classified as under increased threat of extinction.
Ocean acidification has greatly increased over time. This is as a result of increased CO2 emitting in the atmosphere, which has rapidly been increasing over the past 100 years. 30% of these emissions are absorbed by the world's oceans. When the CO2 molecules enter water, it reacts with the water molecules, forming carbonic acid. These then split and release. The increase in hydrogen ions mean a decrease in the pH levels. This image shows how the pH has changed over the last 100 years, with the red indicating more acidic levels. These reefs are home to 25% of the world's marine species and therefore acquire the name the rainforest of the sea, with some of the most diverse ecosystems in the world. Coral reefs cover 0.1% of the world's ocean surface. These reefs typically cover shallow clear waters in tropical seas with temperatures above 17 degrees. The reef is formed from polyps and algae. A polyp is an animal which likes to live in large communities, which comes in an array of shapes and sizes. These polyps secrete a hard carbonated exoskeleton which is used for support and protection. Comes in two types that are important to coral reefs. These both secrete the same carbonated substance. The first, crying algae, looks similar in growth and colour, and it forms many of the corals. The second is calcareous algae, which looks more like your typical plant, but when it dies it calcifies and produces a hard white mineral material. The reason why the coral reefs has been so affected by the CO2 levels is that the residence and mixing time are so large compared with the rapid increase of levels of CO2. This is causing the chemical change in the ocean, which means that the corals are in direct line of fire. This affects the corals in such ways as reduction of ions, such as the carbonate ions, which is used in the exoskeleton, which is used to support and protect them. If nothing is done to stop this, we lose this unique ecosystem.
And is part of the natural attrition process. However, mass bleaching is a concern and may indicate an elevated environmental stress. The main cause for coral bleaching can be attributed to rising sea temperatures. Corals function close to their upper heat limits, and as such, temperatures exceeding just 1 degree Celsius may trigger bleaching. Ocean warming is a manifestation of climate change, caused by the combustion of fossil fuels enhancing the greenhouse effect. Bleaching occurs when the coral is subject to stresses and expels the zooxanthellae within them. This causes the bleached or whitened appearance and reveals the white calcium carbonate skeleton, thus the term coral bleaching. Corals rely on a symbiotic relationship with zooxanthellae algae, which live within the coral polyp tissue. The algae assist in nutrient production through photosynthetic processes essential for growth and survival. However, elevated temperature stifles the algae's ability to produce energy. Although not immediately fatal, bleaching affects the ability of the coral to grow, reproduce, and may increase vulnerability to disease. The coral may survive the bleaching event if environmental conditions return to what is desired and the coral is recolonised by algae. Based on the assumption that corals will not adapt to sea surface temperatures, some authorities anticipate reefs to disappear entirely within 20 to 30 years. One mechanism which may help corals to adjust is for the coral to select a more thermally tolerant symbiotic partner. However, conclusive evidence for just how successful this mechanism is yet to be fully proved. Coral bleaching significantly alters the biological and physical structure of the coral reef habitat. Coral bleaching may be the single greatest threat to abundance, diversity, and community structure of coral reef fish.
The deep ocean is one of the largest ecosystems on the planet, yet is largely unexplored. This world is under threat. Having depleted fish stocks in shallow coastal waters, industrial fishing fleets are extending their range into the deep waters. Trawlers lower weighted nets as big as football fields. These are dragged across the ocean bed, scooping up everything in their path. These coral reefs have taken thousands of years to form, with submarine species living to 200 years. A single pass can decimate these ancient ecosystems. Once destroyed, there is little evidence of recovery, with just bare rock left behind. At the current rate of depletion, deep-sea fish stocks could be exhausted within a decade. Blast fishing is outlawed, although the practice remains widespread in parts of Southeast Asia and coastal Africa. Blast fishing not only kills fish, but it also destroys coral, turning reefs into unstable rubble with little to no chance of recovery. The underwater explosion generates shockwaves that stun the fish and results in the rupturing of their swim bladders, leaving them unable to control their buoyancy. Blast fishing is popular due to the potential for large catch with the minimum effort.